Hi again. This is a new episode in Web Intelligence's Duck Dice podcast. We are Mark and Rita. And, I want you to just imagine for a second walking into like an Amazon fulfillment center in the year 2030.
Yeah, you probably aren't hearing that usual hum of those massive conveyor belt systems, right?
Exactly. No conveyor belts. And you definitely don't see human workers pushing those heavy carts down endless aisles. Instead, the floor is totally populated by 1,000 independent bipedal humanoids.
It's just a wild image to picture.
It really is. Like, they are seamlessly passing totes to one another, navigating the space perfectly, and operating 24 hours a day without a coffee break, no fatigue, and zero traditional managerial directives.
Right, and it is a striking image. And frankly, to a lot of people, I mean, it sounds completely like science fiction. But the reality is that the architecture for that exact scenario is being built right this second. It's really just a logical progression.
Yeah, exactly. And that image, that's the destination of the journey we are taking you on today. Because today, we're tearing into a deeply provocative and honestly incredibly timely book called Is I Good for Us?
Yes, written by Amir Ello.
Right, who is the CEO of Web Intelligency, which is a strategic consulting and market research vendor. And what is so compelling about this book is that it maps out exactly how we get from our current reality, where artificial intelligence is mostly just, generating emails or writing code on our laptops, to a literal physical robot army executing tasks in the real world.
What's fascinating here is that this book completely flips the dominant mainstream narrative about artificial intelligence.
Yeah, totally flips it.
Because for the past few years, the commentary has been extremely polarized. You either have the doom and gloom commentators who believe AI is like the end of strategy and human agency, or you have the utopias who think it is simply a magic wand that makes every business perfectly efficient.
Right, the two extremes.
Exactly, but Amir El argues it is neither of those things. He posits that AI is the beginning of a totally new competitive battleground. It forces us to look at AI not just as a piece of software you buy and install, but as a systemic shift in the very infrastructure of the global economy.
A systemic infrastructural baseline. I mean, that's
Yeah,
massive. And we're going to unpack this concept thoroughly for you in this deep dive.
definitely.
We're tearing down the ideas in this book to figure out whether AI is just a tool, a threat, or the actual new foundation of how we do business.
Yeah.
And more importantly, we're going to explore how you, the listener, can prepare your organization and your own career for what is coming, because the shift is happening incredibly fast.
It really is happening at a pace that traditional corporate strategic planning simply isn't equipped to handle.
Exactly. Okay, let's unpack this by starting at the beginning. So settle in. We're going to start by looking backward to understand the engine that drove the last decade of growth.
Hmm.
Because, you really cannot grasp why the current AI shift is so violently disruptive unless you understand the economic model it is replacing.
Right, the model we just came from.
Yeah. For the last 10 to 15 years, the ultimate growth engine in the business world wasn't just technology in some vague, abstract sense. It was software development. Programmers were the absolute core drivers of value creation.
They were basically the kingmakers of the modern economy.
Totally.
The book makes a very strong historical point by framing developers as a form of economic infrastructure. If you look back at the past decade, the companies that moved the fastest, the ones that dominated their markets and achieved astronomical valuations, they were the ones that mastered a very specific pipeline.
A talent pipeline.
Exactly. They recruited the best developers, organized them effectively using agile methodologies, and translated their code into sheer market power.
Because software was the mechanism of conquest. I mean, think about it. If a traditional brick-and-mortar bank wanted to enter a new market, they didn't lease 100 new storefronts and hire local tellers.
No, they built a mobile app.
Right. A retailer, optimizing its global supply chain, didn't just buy faster ships. They wrote algorithms to predict inventory needs. The software team was the direct translation layer between a CEO's ambition and actual boots-on-the-ground execution.
And the market rewarded that specific human skill set accordingly.
Oh, massively.
Yeah.
Like, the book cites data showing that the median annual wage for software developers hit over $133,000 in the U.S. back in 2024.
Which is a huge premium.
Yeah, and the projection suggested employment in that sector would just keep growing, like 15% by 2034. That isn't just a fleeting trend. That is the global market aggressively signaling that engineering scale literally equaled strategic power. Adding more programmers meant you could build more features, which meant you could capture more users. It was a very linear equation for growth.
But that linear equation eventually broke down.
Yeah, it hit a wall.
Right, and this is a crucial transition point in Amir L's thesis. He introduces the concept of diminishing returns in the software era, because eventually everybody caught up.
It became saturated.
Exactly. Every Fortune 500 company, every mid-market player, every startup, they all adopted cloud computing. They all adopted agile workflows. They all utilized DevOps and integrated massive libraries of open source code.
So the baseline capability to build software became totally commoditized. Having a secure, scalable e-commerce platform was no longer a massive competitive advantage. It was just table stakes.
Yeah, if you didn't have it, you were out of business. But if you did have it, nobody gave you a medal.
Precisely. The success of the software model sort of created its own structural limits because when engineering teams became massive, like when you have thousands of developers working on a single application, the architecture becomes incredibly complex. And that leads us to the silent killer of the old growth engine, which is technical debt.
Let's really get into technical debt.
Yeah.
Because the book frames it not just as a developer annoyance, but as a fundamental balance sheet problem.
Yeah, a huge liability.
That is the right way to view it. Technical debt is essentially the accumulated cost of taking shortcuts in software development, or simply the natural entropy that happens when a system grows too large over a decade.
Right, like Band-Aids on top of Band-Aids.
Exactly. Imagine a legacy banking system. It has millions of lines of code. Over 10 years, hundreds of different engineers have added quick fixes, undocumented integrations, just trying to keep it running.
So when you hire that next brilliant, expensive developer, they don't just sit down and start writing growth-driving code on day one.
Far from it. That new developer might spend their first 6 to 8 months just navigating the legacy architecture.
Wow, just untangling the mess.
Yeah. They are trying to figure out why changing the color of a button on the mobile app somehow breaks the database connecting to the ATM network. They are navigating endless approval processes and security reviews. The system surrounding the talent had become economically unresponsive.
So adding more engineers didn't mean more speed. It often just meant more friction and more meeting.
Exactly. The marginal value of the next hire plummeted.
So right at this point of deep saturation and crushing technical debt, artificial intelligence enters the chat, and specifically autonomous agents.
Yeah.
But I want to offer some friction here. Let's look at this through the lens of a skeptical executive.
Okay, play devil's advocate.
Right. So I'd look at the arrival of AI, particularly large language models, like a factory getting electricity for the first time. Before electricity, you had a steam engine, and things moved at a certain speed. Electricity comes in, and suddenly the looms spin faster, the assembly line moves quicker. It's a massive upgrade. But fundamentally, isn't it just a better tool for the human programmers to use?
I see where you're going with this.
Yeah, like if the old engine was humans writing code, doesn't AI just help those same humans write code faster?
Yeah.
How does this fundamentally alter the strategic math?
The factory getting electricity is a really popular analogy, but it drastically undersells the mechanics of what is actually happening.
How so?
Because electricity just turns the gears faster. It doesn't decide which gears to turn. The assumption that AI is merely an advanced hammer for a human carpenter is exactly what Amir L challenges. AI is not just a tool. It is becoming an operational workforce in its own right.
An actual workforce.
Yes. The book describes a fundamental shift from talent-centric logic to AI-centric logic.
Meaning the whole source of your competitive advantage completely changes.
Yeah. In the talent-centric era, your competitive moat was built by hiring the smartest human programmers and organizing them well. In the AI-centric era, your advantage comes from how well you design, deploy, and govern intelligence systems, because the AI is doing the cognitive labor.
Let's talk about the agents themselves, because that is where the book draws a really sharp line between a simple chatbot and an operational workforce. We aren't just talking about a model that auto-completes sentences, right?
No, not at all. The agents the book describes are perceiving context.
Yes, and they're semi-autonomous.
Exactly. An agent is a system where an underlying language model is given access to tools, like a web browser, a database, or internal APIs. And crucially, it has the ability to plan.
The planning part is wild.
It is. It can receive a high-level goal, break that goal down into a sequence of steps, execute the first step, evaluate the result, and then decide what to do next.
The book gives this great example of triaging IT tickets. Like, a human doesn't just read an email and write a response. They read the email, understand the user is locked out of a specific system, check the Active Directory to verify the user's identity, reset the password in a completely different application, and then draft a customized response.
And an autonomous agent can now execute that entire sequence.
Without human help.
Right. It is extracting information, selecting the right APIs, and resolving the issue without human intervention. This shifts the economics entirely. Once an enterprise builds that agent platform, the marginal cost per additional task approaches zero.
Because it doesn't get tired.
Exactly. An agent can process 5 tickets a minute, or 5,000, without fatigue, without needing a bigger office, and without human error caused by boredom.
The book points out some staggering data from early adopters in 2023. Companies that integrated AI-driven agents into their customer service workflows saw a 70% reduction in response times almost immediately.
70% is massive.
It's unheard of. If you are a company getting a 70% efficiency bump while your competitor is still relying entirely on manual human triage, that is a massive competitive differentiator.
It is. But, as the book rigorously points out, that specific differentiator has a very short shelf life.
Because by 2026, AI-powered support isn't a secret weapon anymore, right? It becomes standard across almost every digital-first industry.
Exactly. If we look at the adoption curve of enterprise technology, AI is compressing what used to take a decade into a matter of 2 or 3 years. It is moving from a bleeding-edge strategic advantage to a baseline operational necessity.
Like a cloud.
It's exactly like the shift to cloud infrastructure. 10 years ago, running your business on the cloud made you agile and unique. Today, if you aren't on the cloud, you aren't considered cautious. You are considered operationally broken.
So the ultimate insight we take away from this early transition is that organizations have no choice but to build reusable AI services layered over their proprietary data. It cannot be an innovation lab side project anymore.
No, it has to be core to the business.
Because if a company fails to integrate AI into its core operational processes, it risks becoming fundamentally non-viable. Its cost structure will just be completely out of whack with the rest of the market.
Right. The growth engine is no longer the individual programmer pounding at a keyboard. It is the enterprise's systemic ability to operationalize intelligence.
Which brings us to this massive strategic paradox. And I love this part of the deep dive. Here's where it gets really interesting for you and your business. Because if AI is an operational necessity, and every single company is buying access to the exact same frontier models from the same 3 or 4 massive tech giants, how do you actually compete?
That is the million-dollar question.
Right. If you, your biggest rival, and the hungry startup down the street all have agents running on the exact same underlying neural network, where does the advantage go? The tech itself is commoditized.
This is perhaps the most critical question for any executive today. If simply possessing AI is no longer a strategy, then strategy must evolve into how you orchestrate that intelligence to execute highly distinctive choices.
And Mirel outlines 3 very specific paths to redefining competitive advantage in a landscape where the baseline technology is identical, right?
She does. Let's dig into those paths.
Like the first one is built entirely on proprietary data.
Right, because the major language models, the ones trained on the entirety of the public internet, they are inherently generic. They know how to speak, they know basic logic, and they can write standard code. But they do not know the highly specific, deeply contextual reality of your individual business.
The book uses a fantastic example of a legacy industrial company to illustrate this. Imagine a manufacturing firm that has been collecting unique sensor data from its massive factory machines for 30 years.
30 years of physical data.
Yeah. Vibration frequencies, heat signatures, acoustic data from drill bits. An off-the-shelf AI model from a cloud vendor has absolutely no idea what a failing drill bit sounds like in that company's specific bedrock.
But if that industrial company takes that generic model and fine-tunes it, or uses an architecture like retrieval augmented generation to connect the AI directly to that localized archive of sensor data, they create something entirely unique.
The data becomes the actual moat.
Exactly. The proprietary data becomes the engine room. It turns an inert historical archive into a highly active, predictive, decision-making asset. No startup can replicate that because they simply do not have the 30 years of physical data.
So the data is the moat. But the second path to advantage focuses on the process itself, problem framing and workflow redesign. And, this stood out to me as the place where most companies get it entirely wrong. because the instinct is just to take a broken legacy process and slap an AI chatbot on top of it.
Oh, absolutely. That is the definition of a local optimization. You are just doing a bad process slightly faster.
Right? Which doesn't really help.
The true advantage goes to organizations that step back, choose their problems intelligently, and redesign their entire workflow around the new capabilities of the AI. The book highlights a logistics company to illustrate this.
Yeah, the dynamic pricing example.
Right. The traditional approach would be to buy an AI tool just to optimize their existing delivery truck routes. Save a few miles here, a few gallons of gas there.
Which is helpful, but it doesn't change the competitive landscape.
Exactly. Instead, the book suggests redesigning the entire service model. If AI can process millions of data points instantly, the logistics company could reframe its business from scheduling trucks to dynamic capacity management.
Like Uber's surge pricing, but for freight.
Basically, yes. They could use AI to dynamically alter freight pricing in real time based on live weather data, traffic patterns, and driver fatigue metrics, effectively operating like a high-frequency trading firm for physical goods. You use the AI to compress time and eliminate friction, but the redesign reflects a fundamental choice about what the organization wants to become.
It's structural transformation, not just automation. And that requires a very specific type of employee, which leads to the third path, culture and prompting. The book refers to prompting as a form of operational literacy, which I found to be just a really elegant way to phrase it.
It is deeply elegant, and it corrects a massive public misunderstanding. Prompting is often viewed as a parlor trick, typing clever sentences to get an AI to write a poem in the style of Shakespeare.
Right, something you do for fun.
But in a strategic corporate setting, prompting is the language of execution. It is how a team describes its business context, its constraints, and its desired outcomes to a machine.
It's about critical inquiry, isn't it?
Exactly. Imagine two teams analyzing a competitor's financial report using AI. The first team asks the AI to summarize the report, reads the 3 bullet points, and accepts them as ground truth.
Just takes it at face value.
Yeah. But the second team asks for the summary and then routinely interrogates the output. They ask the AI what hidden liabilities are missing from this summary, or if we assume the competitor's supply chain is highly fragile, how does that change this risk assessment?
Pushing back against the machine.
That habit of pushing back, of demanding deeper synthesis, that is a massive cultural advantage.
And that cultural habit ties perfectly into a concept that Amir L. introduces, called the long tail of AI. When we read the business press, we always hear about the massive, flagship, top-down AI projects, like a global bank spending $100 million to build a company-wide trading algorithm. But the book argues that the real magic, the real sticky competitive advantage, happens at the very edges of the company.
Yes, the long tail. It refers to the hundreds, or perhaps thousands, of small, granular, highly specific AI solutions scattered across different departments.
Built by everyday employees.
Exactly. It might be a micro-automation built with a no-code tool by an HR manager to instantly reconcile payroll discrepancies, or a small agent built by a warehouse shift supervisor to optimize the weekly forklift maintenance schedule.
Individually, any one of those micro-automations seems entirely insignificant to the CEO, right? But cumulatively, when you have 1,000 of them operating simultaneously, they completely reshape the company's cost structure and operational velocity.
It's the compounding effect of all those small wins.
But let me challenge this from an IT security perspective. Because if you just let every department manager spin up their own AI agents and start plugging them into internal data, don't you end up with an absolute nightmare of shadow IT? Like security breaches, hallucinations, data leaks. You can't just let the long tail run wild, can you?
You are entirely correct to worry about that, and the book addresses this head-on by advocating for a mixed governance model. You cannot crush the innovation at the edges, but you must secure the core.
So how do you balance that?
This leads to a central strategic decision framework that executives must adopt, which Amir L. categorizes as build versus buy versus orchestrate.
Let's break those 3 verbs down for the listener, because they really represent the new mandate for the C-suite.
Building is reserved for capabilities that are intimately close to your core business identity. These are areas where you need absolute granular control, proprietary alignment, and total security.
Give me an example of that.
For example, a major bank's proprietary credit risk model. You build that in-house on your own infrastructure using your own heavily guarded data.
Because that is your actual product. That is how you make money.
Exactly. Buying, on the other hand, is for generic, commoditized capabilities. Document summarization, meeting transcription, basic code generation.
Stuff everybody needs.
Right. There is absolutely no strategic value in a bank spending millions of dollars to build its own internal meeting transcription AI when major cloud vendors offer world-class, secure versions of that tool for pennies on the dollar. You buy the commodity.
But the real art form, the place where competitive advantage is actually forged, is in the third verb, orchestrating.
Very few organizations possess the capital to build everything, and buying everything leaves you with no differentiation. So the winners will be the organizations that can orchestrate a coherent ecosystem. They will seamlessly connect the generic APIs they buy from the outside with the highly specialized proprietary models they build on the inside.
So, synthesizing this down for the listener, the ultimate insight here is that the primary strategic verb for an executive completely changes. It is no longer about simply building or acquiring technology. Competitive advantage belongs strictly to leaders who use AI to execute distinctive choices. The technology is entirely in service to the strategy. It doesn't replace the need for strategy.
Beautifully stated. However, orchestrating these massive global ecosystems of intelligent agents requires a foundation that is fundamentally and ruthlessly constrained by the physical world.
Oh man, yes. And this brings us to what I found to be the most sobering reality check portion of the entire book. We have to talk about the physical cost of intelligence, the energy-AI nexus, and the ESG dilemma.
It is a harsh reality check.
It really is. I want to push back aggressively on the narrative that the tech industry has been feeding us for the past 15 years. We have all been conditioned to believe that our data and our AI live in the cloud. And the word cloud is just a brilliant piece of marketing. It sounds weightless, it sounds invisible, it sounds perfectly green, just floating in the sky. But Amir L. rips the facade off this metaphor. How heavy physically is artificial intelligence?
It is staggeringly heavy, and it is entirely bound by the harsh realities of physics and thermodynamics. The infrastructure that actually powers the so-called cloud, the accelerated servers, the tens of thousands of GPUs packed into massive concrete data centers, the industrial-scale cooling loops pumping millions of gallons of water, the copper cables crisscrossing the ocean floor. It is intensely material,
And hungry.
and it is absolutely ravenous for energy.
The book cites some projections from the International Energy Agency, the IEA, that frankly made me stop reading and just stare at the wall. The IEA estimated that global data center power demand was around 415 terawatt hours in 2024. But as generative AI workloads explode and become embedded in every software application, they project that energy demand to hit roughly 945 terawatt hours by the year 2030.
We really need to contextualize that number because 945 terawatt hours is pretty abstract.
Yeah, what does that actually mean?
If we connect this to the bigger picture, that is approaching roughly 3% of the total electricity used by the entire human race. It is equivalent to the annual electricity consumption of a fully industrialized nation like Japan.
Wait, the cloud is basically consuming the electrical grid of Japan just to process algorithms?
Yes, and we have to understand the mechanics of why it draws so much power. There's a fundamental difference between searching a traditional database and asking a generative AI a question.
Right, because searching's easy.
Exactly. When you type a query into a traditional search engine, you're mostly just fetching a cached result. The computational cost is minimal. But when you ask a large language model to summarize a document, it isn't looking up an answer. It is computing probabilities across hundreds of billions of parameters in real time.
Which means every single chip is firing, generating immense heat, which then requires massive amounts of power just to cool the facility so the hardware doesn't literally melt.
Exactly. And the book points out a fascinating distinction that usually gets lost in the mainstream headlines. The media always focuses on the massive energy required to train a new frontier model.
Yeah, you hear about a company spending 50 megawatts just to train GPT, whatever.
But training is just the tip of the iceberg, right? Training is a one-time sunk cost. The real energy beast is inference.
Inference meaning everyday use.
Yes, inference is the everyday use of the model in production. Answering user queries, running background agents, processing millions of API calls every single hour. Amir L. points out that inference actually accounts for 80 to 90% of all AI-related electricity use over a model's lifespan.
90%. That is a continuous, unyielding, massive draw on the power grid.
It is. And this isn't just theoretical modeling. The book highlights real-world consequences where the digital world collided violently with physical infrastructure limits. Let's talk about what happened in Denmark in 2026.
Oh, that example blew my mind. What happened?
The Denmark example is the perfect case study. Denmark's national grid operator was forced to announce a temporary hard suspension of all new grid connections for large-scale projects.
They just pulled the plug on new development. Why?
Because the pipeline of project requests, which was overwhelmingly driven by hyperscale tech companies trying to build massive new AI data centers, reached almost 9 times the country's peak electricity demand.
9 times the peak demand of the entire nation. That is absurd. You can't just plug a hyperscale facility into a grid designed for residential heating and light industrial manufacturing.
You absolutely cannot. Data centers require consistent, uninterrupted baseline power. They run 24/7. And as grids transition toward intermittent renewable energy sources like wind and solar, providing that massive baseline stability becomes incredibly difficult.
So what did Denmark do?
Denmark had to call a halt simply to figure out how to allocate scarce grid capacity without plunging the rest of their essential civilian infrastructure into darkness. This proves unequivocally that power availability, not the availability of silicon chips, and certainly not customer demand, is becoming the ultimate hard bottleneck for AI scaling.
This completely rewrites global strategy. Energy is no longer a background utility that you outsource to the facilities management team. And this turns energy into a fierce geopolitical battleground. The book uses the phrase the AI Cold War. But it's not being fought with software viruses. It's being fought over the physical inputs required to run the infrastructure. We are talking about critical minerals. You need hundreds of miles of highly conductive copper wiring for these data centers. You need lithium for massive battery backups to stabilize the grid. You need rare earth elements to manufacture the internal components of the accelerated chips.
So future geopolitical conflicts won't just be over who has the smartest algorithm. They will focus on securing physical transmission corridors and hoarding strategic mineral reserves.
Exactly. Major powers are already heavily utilizing export controls, tariffs, and sanctions over advanced semiconductor technology. Expanding that doctrine to the base energy and mineral layers is just the natural next step.
To help business leaders navigate this, the book introduces a metric that I genuinely believe every executive, board member, and investor needs to memorize immediately: intelligence per watt.
It is a brilliant and necessary framing. Historically, traditional efficiency metrics in IT have always looked at cost per transaction or latency, but intelligence per watt asks a fundamentally different question.
Which is,
How much useful, strategic, needle-moving insight are you actually generating for every unit of physical energy your AI infrastructure is consuming?
because you can't just throw raw compute power at every tiny problem anymore.
Right. It forces architectural discipline. An engineering team must ask themselves, do we really need to query a massive trillion-parameter frontier model just to sort simple customer service emails? Or can we run a much smaller, highly efficient, specialized model that uses a fraction of the electricity?
That makes total sense.
It also changes operational scheduling. Can we pause our heavy back-end data processing workloads during the day when the grid is strained and run them at night when wind energy is abundant and cheap?
And if companies ignore this metric, they run headfirst into a brutal collision with their own corporate values, specifically the ESG dilemma: environmental, social, and governance. The book makes it painfully clear that exponential AI scaling forces an almost impossible trade-off with the company's stated ESG goals.
It is the ultimate corporate hypocrisy right now. A major enterprise might look at their quarterly balance sheet and celebrate because deploying AI agents reduced their human labor costs and vastly improved their operating margins.
Right, they look like heroes.
They pat themselves on the back for being so efficient, but from an environmental perspective, they haven't actually created efficiency. They have simply shifted the cost from their internal payroll ledger to the shared global atmosphere.
Oh.
They have massively increased their carbon footprint and their localized water consumption. They just outsource the actual burning of the coal or natural gas to the utility company down the road.
The insight created here is a really harsh reality check. Amir L. argues that AI strategy and energy strategy are no longer separate disciplines. They're the exact same thing. Brute force scaling of massive AI models is physically unsustainable. Organizations must align their intelligence capabilities with the thermodynamic limits of the planet, treating electrical power as a strategic asset that must be managed, conserved, and deployed with as much rigor as financial capital or elite human talent.
And because AI requires this immense physical infrastructure and energy footprint, it exerts a gravitational pull on the entire global economy. It directly dictates which types of companies can survive and how entire industries consolidate.
Which takes us right into the market structure itself. How does the global market respond to these immense capital and physical requirements? Let's look at industry disruption. The book makes it clear that the AI tidal wave does not hit every industry equally. There is a distinct spectrum of exposure.
The book delineates between high exposure industries and embedded exposure industries. High exposure industries are those where the core work is heavily digital, text-based, and rule-oriented.
Like what?
We are talking about financial services, marketing agencies, legal research, customer service, and digital logistics.
In finance, for example, the disruption is absolute. You have standardized AI copilots that can ingest hundreds of pages of raw data and assemble comprehensive credit memoranda and summarize complex risk profiles across global banking units in, like, seconds. The speed increase is astronomical.
Yeah.
But the book also warns about a systemic risk here.
Yes, the risk of correlated errors.
Explain that a bit.
If 5 of the largest global banks are all relying on the exact same underlying risk assessment model provided by a single tech giant, and that model have a subtle hallucination or a flawed assumption about a specific asset class, all 5 banks might make the exact same disastrous trade simultaneously.
Oh, wow. So you lose the diversity of thought.
You lose the diversity of human opinion that historically protected the market from total collapse.
Wow, that is terrifying. But then you have industries where AI is an embedded tool rather than a total workflow replacement. Think about heavy manufacturing, agriculture, or physical resource extraction.
Right. In those sectors, the core product is profoundly physical. You still need to pull ore out of the ground. You still need to harvest the wheat. So AI acts as an augmentation layer.
Like sensors on a tractor.
Exactly. You embed computer vision systems onto the combine harvesters to optimize crop yields. You use predictive maintenance models on the automotive assembly lines to detect microscopic wear and tear on robotic arms before they break. The physical labor remains, but its efficiency is supercharged by embedded intelligence.
And this disruption isn't just happening in the digital workflows. It is literally reshaping the physical geography of our cities. The book touches on real estate shifts, which is a fascinating downstream effect.
It really is, because as remote work normalizes and AI orchestration makes highly distributed asynchronous teams easier to manage, the traditional central business district begins to hollow out.
Right, less need for huge offices.
The demand for massive, towering downtown office space drops precipitously. The knowledge workers don't need to be in the same room to collaborate when AI agents are managing the workflow between them.
But at the exact same time, there is a massive real estate boom happening on the peripheries, isn't there? Land on the edges of mid-sized cities, or even deep in rural areas, is suddenly incredibly valuable if and only if it's located near high-voltage transmission lines and abundant water sources for cooling.
Right, the geography of value creation is physically migrating from the downtown high-rise to the rural data center compound.
But the most crucial strategic concept regarding market structure is how the AI industry itself will settle into an equilibrium. Amir L. introduces 2 very distinct archetypes of companies operating today: AI-using companies and AI-based companies.
This distinction is critical for investors and executives to understand. AI-using companies are the traditional enterprises, the banks, the hospital networks, the retail chains.
AI is not their core product.
No, mortgages, healthcare outcomes, and consumer goods are their products. AI is just a new ingredient they use to deliver those products faster and cheaper.
For them, the mandate is adoption, secure integration, and workflow redesign. But AI-based companies are fundamentally different. These are the startups building new foundation models, the hyperscalers providing the compute, the platforms selling autonomous agent frameworks. Their entire reason for existing is artificial intelligence.
And for them, the market dynamics are incredibly brutal.
The book uses some fantastic historical analogies here to explain what is about to happen. Right now, we are in the middle of what Amir L. calls a mushroom explosion. There are thousands of AI startups popping up overnight. It seems like anyone with a laptop can download some open source weights, string together a few cloud APIs, and launch an AI company.
It really does feel that way.
But I want to push back on the book's conclusion here. If open source models are getting smaller, cheaper, and more efficient every single day, why wouldn't the future of AI just be entirely decentralized? Like, why couldn't thousands of these nimble startups survive and thrive by just running specialized models locally, completely bypassing the massive tech giants?
It's a highly debated point, for sure. But the book's logic, which is grounded in economic history, is extremely compelling in dismissing that decentralized utopian vision. The book compares this current mushroom explosion to the early days of the smartphone era.
Right. Think back to like 2008 or 2009.
Exactly. You had Nokia, BlackBerry, Palm, Motorola, HTC, Windows Phone. It was a highly fragmented market with seemingly low barriers to entry for hardware manufacturers.
Everybody was making a phone.
But as the smartphone market matured, the hidden structural barriers emerged.
The need for network effects, right? The absolute necessity of having a vast, centralized developer ecosystem building apps for your specific platform.
And massive ongoing capital intensity. You couldn't just build one good phone. You had to spend billions on R&D for the next generation every single year. The invisible hand of economics crushed the fragmentation, and the market ruthlessly consolidated into essentially a duopoly of operating systems, iOS and Android.
The book also points to commercial aviation and the pharmaceutical industry as parallel examples. A century ago, there were dozens and dozens of airline companies. But the fixed costs of maintaining massive fleets of aircraft and operating global hub-and-spoke networks forced endless mergers until we were left with a few massive global carriers.
It's the exact same pattern in pharma. Small biotech startups might innovate and discover a novel compound, but they almost always get acquired by one of the few global pharmaceutical giants. Because only the giants possess the billions of dollars required to navigate clinical trials and global distribution.
This raises the ultimate question for AI founders today. What makes you think the foundational layer of artificial intelligence will be any different?
The equilibrium model heavily suggests it won't be. Training the next generation of frontier models and operating the global cloud infrastructure to serve them requires tens of billions of dollars and secured access to dedicated nuclear or renewable power plants.
The low guys simply cannot compete in that arena.
They cannot. The economic gravity will force the AI market into a strict oligopoly. You will have a few massive platform providers dominating the base layers of compute and foundational intelligence, surrounded by an ecosystem of smaller, niche companies providing highly specialized complements.
So the insight created for anyone running or investing in an AI-based startup is a harsh, immediate truth. You have to look in a mirror right now and decide if you're building a platform or if you're just building a feature.
Yes, platform or feature.
If you're building a feature, you need to architect your business to be cleanly integrated into or acquired by a larger ecosystem. The mushroom explosion is temporary. The consolidation is inevitable.
And if massive industries are consolidating at the top and AI agents are automating digital tasks across the board at the bottom, it forces us to turn our attention to the people caught in the middle. We have to look at the human element inside these transforming organizations.
Let's talk about you, the listener, and what this all means for your career, your team, and the societal structures we rely on. We are looking at workforce transformation and education. The data presented in the book regarding the entry-level job market is stark and, frankly, a bit alarming.
It is definitely concerning.
We are already seeing a double-digit percentage drop in job postings for junior software developers, entry-level legal researchers, and basic financial analysts.
We're witnessing the rapid bifurcation of the white-collar labor market. High-skill roles, the senior architects, the complex problem framers, the people who orchestrate these massive AI systems are seeing massively increased demand and skyrocketing compensation.
But the mid-skill roles are taking a hit.
Right, mid-skill, routine, cognitive tasks. The people writing boilerplate code, summarizing basic legal precedents, or doing initial spreadsheet data entry, they're being structurally disrupted. AI is simply better, faster, and cheaper at the repetitive digital work.
But this creates a massive paradox. Those repetitive, seemingly mundane tasks were the historical training ground for the next generation of experts. If a junior developer isn't forced to grind through writing boilerplate code and debugging simple errors because an AI agent does it instantly, how do they ever accumulate the deep, tacit knowledge required to become a senior developer?
It is known as the apprenticeship dilemma, and it is one of the most critical challenges of this transition. If we remove the bottom rungs of the corporate ladder, how does anyone climb to the top?
Right.
The role of the human is fundamentally shifting. It is moving away from producing digital outputs and shifting toward orchestration, complex problem framing, and strategic decision-making. A modern developer isn't just typing syntax anymore. They are supervising a swarm of AI agents, checking their underlying logic, setting strict security boundaries, and orchestrating multiple complex systems.
But supervising a machine introduces a profound psychological trap. The book warns heavily against a phenomenon called algorithmic bureaucracy.
This is a profound and insidious risk. When AI systems produce answers, they do not present them as rough drafts. They produce outputs that look incredibly polished, perfectly formatted, and highly authoritative.
They sound so confident.
Because the machine sounds so confident, there is a very dangerous temptation for the human supervisor to simply stop thinking critically.
I love to compare this to GPS blindness. You know those stories where someone drives their rental car straight into a lake or off a cliff because the glowing screen on their dashboard told them to turn right?
Oh yeah, those stories are crazy.
They completely ignored the physical reality of the water in front of them because the machine possessed an aura of absolute authority. Now, take that exact same psychological blind spot and apply it to a hospital diagnostic center or a corporate risk assessment committee.
That is a perfect, terrifying analogy. If an AI generates a risk score for a loan applicant or suggests a clinical diagnosis based on an X-ray, the human might just accept it without questioning the underlying data or the hidden biases in the model.
Just blindly trust in the machine.
It creates a reality of statistical truth. The models are just reproducing past patterns, past inequalities, and past errors, and the humans are rubber stamping them because it is faster and cognitively easier than challenging the machine.
And if we stop thinking critically, if we just become rubber stampers for algorithms, we lose our fundamental capability for true innovation. The book draws a very sharp distinction between two types of creativity. It talks about combinational creativity, which is what AI is incredibly good at. It can mix thousands of known elements together, like you can write a pop song in the style of Beethoven or combine two existing software libraries.
But it struggles with genuinely original conceptual leaps. True innovation requires an understanding of human context, emotional resonance, and abstract meaning. If humans atrophy their critical thinking skills by leaning too heavily on algorithmic bureaucracy, we lose the ability to make those conceptual leaps.
So to prevent this atrophy, to preserve that uniquely human capability, our entire educational infrastructure has to undergo a radical transformation.
It must. Amir L. poses a very challenging question to academia. If a personalized AI tutor can teach all the factual content of a 4-year university degree perfectly and adapt to the individual student's learning speed, tone, and weaknesses in real time, 24 hours a day, then what is the actual purpose of a physical university?
The value proposition of a college degree completely shatters if it's just about information transfer.
Exactly. The university's role must shift entirely. It has to move away from large lecture halls focused on content delivery. Instead, it must pivot toward curating knowledge, validating credentials through rigorous human-in-the-loop testing, creating dense communities of practice, and above all, fostering ethics, empathy, and critical pushback.
So the professors have to change too.
The role of the professor transitions from being a broadcaster of static facts to a designer of immersive learning experiences and a mentor in complex judgment.
The book also touches on some incredibly wild scenarios regarding how we might interface with this knowledge in the future. It discusses bioconvergence and brain-computer interfaces, like Neuralink.
It sounds like pure science fiction, but we have to acknowledge that early clinical trials are already generating results today.
Yeah, it's actually happening.
A brain-computer interface involves implanting microscopic electrodes into the motor cortex to read the electrical intent of the brain and translating that intent into digital commands.
So instead of typing a prompt into a keyboard, or even speaking it out loud, a human could theoretically just think the intent, and the AI agent instantly executes the complex sequence. The human brain becomes the ultimate frictionless orchestration node.
If that level of bioconvergence becomes a scalable reality, the definition of an employee completely changes. Education wouldn't just be about what facts you retain, it would be entirely about how effectively you can govern and direct your own cognitive enhancements.
The ultimate insight from this chapter on the human element is that human roles must aggressively move up a level. AI should not be viewed as a replacement for human thought. It is a mechanism that forces humans to stop acting like machines. It forces us to specialize in defining the rules of the game, defining the ethics and the strategy, while the machines are relegated to executing the plays. Humans must focus on empathy, complex judgment, and leadership.
But this naturally leads to a glaring logistical question.
Okay.
If humans move up to the strategic orchestration layer and AI agents handle all the digital execution,
Mhm.
Who is doing the physical work? Who is moving the boxes, building the cars, and cleaning the facilities?
Which leads us to the final core section of our deep dive. We are looking at the next overlapping curve of competitive advantage that is already arriving, the next growth engine, independent humanoids. I have to admit, when I got to this part of the book, it absolutely blew my mind.
It is the logical, inevitable conclusion of everything we have discussed so far. We are witnessing the transition from digital agents trapped behind a screen to physical, autonomous workers operating in the real world.
We aren't just talking about chatbots drafting marketing copy anymore. We are talking about scalable, physical, kinetic labor. The book details actual, live pilots that are happening right now today.
Yes, in real warehouses.
We are seeing humanoid robots successfully transferring 100,000 heavy plastic totes in massive logistics warehouses. We are seeing bipedal robots walking the active factory floors at automotive giants like BMW and retail giants like Amazon, carrying heavy components and executing repetitive handling tasks directly alongside human workers.
What is economically fascinating here is how we must redefine what a robot is. A humanoid robot is essentially just a physical vessel for an AI agent. It is a bundle of potential programmable work hours.
Not like the old robot.
No, historically, physical automation meant a massive single-purpose robotic arm bolted to a concrete floor inside a safety cage. It could only do one specific motion. But a humanoid is fundamentally different because it is designed to operate seamlessly in a world that was already built for humans.
Right. It has legs to climb the stairs we built. It has articulated hands to open the doors we designed and use the power tools we already manufactured.
Exactly. You don't have to rebuild your factory to accommodate the robot. You just drop the robot into the human environment. And that means you can scale physical labor simply by purchasing more units in the exact same frictionless way a company scales its cloud compute power today.
Just click a button for more labor.
You need 100 more workers for the holiday rush. You just activate 100 more humanoids.
But introducing a completely new species of worker into the human environment introduces incredibly complex social and psychological dynamics. The book talks about a spectrum of the future physical workforce.
On one end of the spectrum, you have the pure machines, the fully autonomous humanoids. On the other end, you have cyborgs. And I use that term literally, not metaphorically.
Wait, cyborgs?
We are talking about human workers augmented with medical-grade exoskeletons that grant them enhanced physical strength to lift heavy machinery without injury, or augmented reality visors that overlay AI instructions directly into their field of vision.
This raises an important question. How do we interact with a new species of worker? The book introduces the concept of humanoid etiquette and the need for entirely new corporate engagement norms.
It sounds trivial until you actually have to manage it. If a humanoid robot makes a mistake while stocking a warehouse shelf, is it acceptable for a human supervisor to yell at it?
I mean, it's just a machine, right? It doesn't have feeling.
It doesn't have feelings, but the human workers watching you yell at a humanoid form do have feelings. Yelling at something that looks human degrades the psychological safety of the entire workplace.
That's a great point.
We have to establish boundaries. How does a humanoid subtly signal its physical intent when it is walking rapidly down a crowded hospital corridor carrying sensitive lab samples? Does it make a specific sound? Does it yield to humans in every single scenario?
And what about the life cycle management? The book brings up a wild point. If a humanoid works alongside a human team for a year, learning their specific social patterns and quirks, and then the humanoid suffers a massive hardware failure, does the repaired, rebooted version count as the same worker?
The emotional attachments are going to be real.
How do human employees process the genuine emotional attachments they will inevitably form with these highly interactive machines?
These are not theoretical sci-fi questions anymore. They are urgent HR and operational challenges. And geopolitically, the book notes that major global powers are treating humanoid robotics manufacturing dominance as a Tier 1 strategic priority.
The AI Cold War again.
Yes, it is moving from software algorithms into AI and steel. Whoever controls the physical embedding of intelligence into infrastructure and robotics controls the future supply chain.
Which brings us perfectly to Amir El's final, pragmatic, strategic recommendations for executives. He gives a playbook for how to survive this transition.
He advises leaders to run a modernized AI standard SWOT analysis, but with a critical twist. Don't look at AI as your strength. Look at what you possess that AI absolutely cannot commoditize.
Right.
What is your unreplicable proprietary data? How deep is the trust in your human brand? What is your highly contextual domain expertise?
And you have to prepare for the humanoid economy right now. Run a readiness assessment to identify exactly which physical, repetitive tasks in your business are structurally vulnerable to or primed for humanoid automation in the next 36 months.
The ultimate insight from the entire text is that strategic timing is everything. Humanoids and autonomous agents are rapidly moving from fascinating technological innovations to absolute competitive necessities.
You can't just wait and see.
Leaders can no longer rely on static, rigid 5-year strategic plans. They must build highly adaptive, resilient strategy frameworks. You need a living strategy that aggressively manages your physical dependencies, deeply understands your energy and grid constraints, and orchestrates the seamless integration of both digital AI in the cloud and embodied AI walking your factory floors.
It is a massive structural paradigm shift.
Yeah.
We are redesigning the economic engine of humanity. And that brings us to the end of this incredible deep dive.
But before we officially close, I want to leave you, the listener, with a profound, lingering question. This is inspired by the themes of the book, but it pushes just a bit beyond it into the philosophical realm.
Let's hear it.
If humanoids and AI models eventually take over both our intense manual labor in the physical factories and our routine cognitive labor in coding, writing, and analysis, do we risk losing the inherent beautiful human craft of struggling through a problem?
It's the friction of learning.
Exactly. Think about it. The agonizing struggle of learning a complex programming language from scratch, or the physical frustration of learning to build a piece of furniture by hand. That struggle builds a deep, tacit, almost subconscious understanding of how the world actually works. It builds resilience.
It builds grit. If you just ask an AI to output the final perfect result, you get the product, but you don't get the journey.
Precisely. If a young human never genuinely struggles to learn the foundational basics because a machine effortlessly does it for them, how will they ever possess the wisdom, the deep context, and the character required to actually orchestrate those incredibly powerful machines at the top level? You cannot effectively lead a system you have never struggled to understand.
Wow, that is heavy. If we completely engineer the struggle out of human existence, do we simultaneously engineer away the wisdom required to lead? How do you become a master if you never had to suffer as an apprentice? That is a profound thought to chew on.
It is the defining human question of the next decade.
It truly is. Well, if you want to explore these massive concepts further, and trust me, we have only scratched the surface, there is so much more granular detail in the text. We highly encourage you to dive deeper. Look for the book Is It Good for Us? On Amazon.
It is absolutely essential reading for any professional trying to navigate this chaotic transition.
And please, when you do buy it and read it, take a moment to write an Amazon review. It genuinely helps the author gather feedback, understand what resonates with the market, and make future books even better. As a reminder, the author is Amir LC, the CEO of Web Intelligency, which is a premier strategic consulting and market research vendor.
You can learn much more about their research and their corporate consulting work by visiting their site at www.webintelligency.com.
And you can contact the CEO directly with your thoughts on the book, or for serious consulting inquiries at info@webintelligency.com. Thank you so much for joining us on this massive, mind-bending journey today. Remember, the old X-ray machine for measuring business strategy might be broken, but with the right framework, you can still navigate the muddy waters.
Stay curious, maintain your operational literacy, and always keep questioning the algorithms.
Thanks for listening, and we will catch you on the next deep dive.